Hi, on today's lesson we're going to be looking at the sine law, and sine law comes into play when we're looking at triangles that are not right angled. So if you remember our other lesson where we dealt with all of our trig ratios, and we mentioned that those are only valid for when we have a right angle triangle. Now we're going to look at when we have acute angle triangles that are not right angled. So when we have triangles, we will label the vertices, so all the corners will get labeled with our capital letters. And then the side opposite gets labeled with the same letters. So if we see this is angle A, so if we go opposite angle A, that's going to get a label of A, but now we write them in lowercase. So I'm just going to put that in. And sine law allows us to find either an angle or a missing side. And I'm just going to write out that rule here. So there's two ways to look at it. So we can either first say sine of A over side A is equal to sine of B over side B is equal to sine of C over side C. Another way of writing that is if we just flip all of our fractions over, and that gives us A over sine A is equal to B over sine B is equal to C over sine C. So that's our sine law. So we're going to look now at how we apply that law. So in this example here, we've got our triangle EFG and we want the length of FG. So I'm just going to highlight that length so you can just see what we're looking for. We want that one over there. Okay, so we want FG correct 2 decimal places. In order to find a missing side, we have to make sure that we know the angle that it's opposite. So if you look here, in this scenario, the angle opposite is 48, so I already have that. And then I would need one other side, which I have. There's my other side. I've got 21. And I need to know that I've got the angle opposite there, and I do. When we're looking for a missing side, we want to use this rule where the sides are in the numerator of the fraction, okay? So we're going to put FG all over, and then we have to do the sine of the angle opposite, so that would be 48. Equals, and then we have the side that we know. Now we're not going to say EG because that makes no sense because we don't know what EG is. So we're going to go 21 over sine of 71. And in order to isolate FG, we have to remove the sine 48. So sine 48 is being divided, so we need to multiply. So we get FG is going to be 21 times sine 48 all over sine of 71. And it's at this point that you use your calculator. So that's another important thing. Notice how I didn't evaluate this part here using my calculator because then I would have a decimal and I'd be rounding. We don't need the calculator until we get to this point here. Okay, so now remember your calculator has to be in degrees. So just make note of that. Make sure you're in degree mode because if you are not, you're not going to get the right answer. So 21 sine 48 all over sine 71. And the question is asking us to go to 2 decimal places. So that gives us approximately 16.51. And remember, they have given us units of centimeters, so we have to give units in our answer. This is not a word problem, so we don't need to write out a sentence answer. Okay, so now let's look at this example. So here we have triangle ABC, and they want the length of BC. So I'm just going to, again, just highlight that so we know what we're looking for. That's what we're looking for. Now, in order to use sine law, remember, I need the angle opposite. So now we're in a problem. We don't have that angle. However, we do know two angles in my triangle. So if you can remember, angles in a triangle add up to 180. So this angle over here is actually going to be 180 minus, and then I have to add those other two angles that we know, because the three angles in a triangle will all add up to 180. So we know that that angle in there works out to be 57. And now I am able to use my sine law again and calculate what I will get for BC. So again, I'm looking for a side length, so that goes at the top. So BC over sine of 57 is going to equal, and then remember, we're going to use the side I know, so 44. Over sine of 88. And that is the same procedure as we had. So we're going to go BC is going to equal to, so we have to take this sine 57 and multiply it up to the top. And now is when we're going to pull out our calculators and calculate that answer. So you're going to go 44 sine 57 over sine 58. And again, we're asked for two decimal places. So we're going to go 43.51. And we were given units in our question, so we're going to give units in our answer. Okay, so now we're going to look at this question here, where they want the size of theta to the nearest degree. So we just want to make sure we have everything we need. So I've got theta is what I'm looking for, and I have the side opposite, and then I've got another angle and its opposite side. So I'm good to go for my sine law. Now we're solving for an angle. So when we're solving for an angle, we want to use this part, where the angle values are at the top. Okay, so we're going to say sine of theta over, and then there's 6, that's opposite, is equal to, now I'm not going to say sine of r because one, I don't know what it is, and I don't even have the value opposite. So sine of 51 over 9.4. So in order to get the theta, I'm actually first going to have to get sine theta by itself. So to do that, this 6 that's being divided is going to get multiplied. So we're going to say sine of theta is equal to 6 times sine 51 all over 9.4. And we're still not going to use our calculators because we're not there yet. We want theta. Okay, so if you can remember in the section that we did with our trig ratios, in order to get theta, I need to remove sine. But sine is not being multiplied. So remember, sine is a function. So we have to inverse that function. So we have to go theta is equal to inverse sine. So that's not sine to the power -1. It's inverse sine. And now what we need to do is pull out our calculators and work this out. So remember, your inverse sine will be above your sine key. So you're going to either second function or shift, and then you'll get your inverse sine. And then we go 6 times sine of 51, all divided by 9.4. And that will give us 29.7, but remember our question is saying nearest degree, so that will round to 30 degrees. So we're going to approximate that as 30 degrees. Okay, so in the first few examples that we've just done, we were given the diagram already and then asked to solve. In this scenario, the triangle is being described to us, and we have to first always write or draw out your diagram. So when you get a description of a scenario or of a triangle, before you start trying to see it all in your head to work out your solution, take that time to just draw out the triangle. So here, it doesn't really matter what it looks like. So that's another thing. Like, you don't need to draw anything to scale. You don't have to draw anything to proportion. You are just going to draw it in. We know it's called X, Y, Z. So we are just going to label my vertices X, Y, and Z. It does not matter how you do that. What matters is that now when you put your values in, you put them in the right place. So it says that side Z is 58. So my angle Z is here. So across from that is where the side Z is. So this is given as 58 centimeters. And then angle Z is given as 38 degrees. Angle Y was given as 72 degrees. And we want the length of side Y. And this is where side Y is. Okay. All right, so now that we've drawn out the triangle, it's much easier for us to see how we would apply sine law. So this is what I'm looking for. It's this side over here. And I already know the angle value that's opposite that side. And then I have another side and its angle, so I'm good to go with my sine law. So we're going to say, and remember we're looking for a side this time, so the side at the top, y over sine of 72 is equal to 58 over sine of 38. In order to get y by itself, we're going to take this whole sine 72 and multiply it up. So 58 sine 72 all over sine 38 is going to give us and now is where you're going to have your calculator out and punch all of this into your calculator, and you will get 89.5, well, it's 5, 9, and then it goes 6, 7. So that 9 is going to bump up to a 10, which then will change this to 89.60. And remember, they gave us units in our question. So we are going to put units in our answer. Okay, so here's a word problem. So these are more of your thinking level questions, just because you really need to be able to take all of these words and translate them into a diagram. So I wanted to just do one example of that. So it says 2 boats that are equipped with sonar equipment are 20 meters apart. The crew on both boats detect an object under the water between them. So let's look at that part. So we're going to have 2 boats and an object between them. So that's going to create the triangle. And remember, doesn't matter how you draw it, as long as you draw a triangle. It doesn't matter what the dimensions are, because we're not drawing anything to scale. I am going to call this one here B1 for the first boat, and I'm going to call this one here B2 for the second boat, and you could call them whatever you wanted, because that doesn't matter. It's your diagram to help you answer the question. When you're being graded, you will generally be graded on having a diagram that is labeled and that has all of the measurements put in the right place, but it doesn't matter what your labels would be. Okay, so we have your boats, and they're 20 meters apart. That means this distance here is going to be 20 meters. And now we talk about something called angle of depression. So I wanted to just explain to you, so I'm going to shift to the side here, and just explain to you what this term means. So angle of depression. This is if you were to be looking straight across, okay, how much would you have to look down? So straight across is like you're parallel to the horizontal, okay? So if you're looking straight across, by how much do you have to angle your vision downwards to see something? So if we had the object down here, this is your angle of depression. It's how much does your sight line, or how much do you have to look downwards in order to see something? And then the opposite of angle of depression is your angle of elevation. An angle of elevation is if you are standing and looking across, how much do you have to angle your vision upwards in order to see an object? So angle of elevation can be used if you are at the bottom of a building and your friend is waving at you from a window at the top of the building. What is the angle of elevation to look up at your friend? That's angle of elevation. Angle of depression could be if you are at the top of a tower and you see your car at the bottom on the road. What is the angle of depression for you to see that car? And so that is your angle of depression. So in this case, we are talking about the boats and that object between them. So for boat 1, the angle of depression, so from looking across, how much would they have to look down to see that object, is 47 degrees. And then for boat 2 to look down, that is 40 degrees. And we are asked which boat is closer. Well, in order to know which boat is closer, I would have to find both of the distances and compare them. So because I've called this side B2, or this angle B2, I'm going to call the opposite side just a lowercase b and 2. And I'm going to do the same thing over here with B1. And so we have to find both of them. So sine law is going to come into play again. However, we are going to need to find the value of this angle. So in order to find that value, remember we have to use our sum of angles in a triangle. So 180 minus, and then we have to go 47 plus 40. And when we do that, we get 93. So there's our 93 in here. Okay, now we're good to go. So we're going to let's just find B1 first. And remember, we're solving for a side, so we put the side at the top. All right, so we're going to go B1 over, and then we need sine of 47 is going to equal to, now I'm not going to say B2 because I don't know what B2 is. So we're going to go 20 over sine of 93. And that gives us B1 is equal to, and now we're going to have to work this out on our calculator. So we're going to go 20 sine 47 over sine 93. So when you put all of that into our calculators, we get an answer of 14.65. I'm going to go to 2 decimal places. That's a good convention to use. And this is in meters. Okay, so that's B1's distance. Now let's work out B2's distance. So we're going to say B2 over sine of 40 is equal to. And now in this case, I don't want, even though I have figured out B1, because now I know that B1 is approximately 14.65. I don't want to use my B1 over sine of 47 because if I've made a mistake in calculating this, I'm going to carry that mistake down. And in this question, I have the option to use a given value. So whenever you can use what was given over what you've calculated, always go with what was given. So we're going to say 20 again, all over sine of 93. So that B2 is going to be 20 sine 40 all over sine of 93. And this is where our calculator is going to come into play. And this will give us 12.87 meters. So we can now give our answer. So we will say, therefore, boat 2 is closer to the object. Okay, and that's it for the lesson on sine law.